No other place in the world has as many seams 50 feet or more thick. But the Powder River Basin is not only an economic resource. To geologists, it's also an intriguing scientific enigma. Geologists have been studying the basin for more than a century, largely to answer a baffling question. How did the seams get so massive? Or more precisely, why weren't the seams diluted by influxes of clay and other impurities before they thickened? As McClurg puts it, how on earth did things remain constant enough so that you can get 200 feet of coal? The genesis of any kind of coal demands a precise sequence of events, however. If you don't get all of them, you don't get coal, explains McClurg. And to get seams more than 200 feet thick, low in impurities and low in sulfur, is a remarkable achievement. He adds, it would be like blindfolding yourself, spinning around and hitting the center of a dartboard 100 times in a row. But if coal did not form slowly, is there any laboratory evidence showing that it can form rapidly? In this demonstration, Robert and David Gentry begin to answer this question.
Earlier we took a piece of wood like this, inserted it in this steel pipe, added some water, and then sealed it up. The next step is to put it in the oven at about 160 degrees centigrade for 2 weeks. Now we're ready to examine the results of this experiment.
As we can see, this wood is now darker in color. It's also softer. A chemical reaction between the steam and the wood under pressure has caused these changes to occur. This specimen isn't coal yet, but clearly the process of coalification has begun.
The question is, would coal result if this experiment, or a variation of it, continued for a longer period of time?
Scientists at Argonne National Laboratory have answered this question in a series of experiments performed in the 1980s. One of the earliest reports about their work appeared in the magazine Chemical and Engineering News in the November 21, 1983 issue. On page 42 of this issue, we read the following quote: "Chemists at Argonne National Laboratory have succeeded in making a type of artificial coal from naturally occurring materials. The process is much less severe than formerly thought to be necessary and provides some new insights into coal structure and how to alter it." Later, after their published reports appeared in the science journal Organic Geochemistry, the British science journal Nature reported on the success of their experiments. On page 316 of the journal Nature, March 28, 1985, we read the following. Winans and his colleagues at Argonne National Laboratory have taken less than 1 year to prepare a thoroughly characterized synthetic coal. The material they produce is indistinguishable from the real thing by all the techniques so far applied to it, and its synthesis raises many interesting questions in coal chemistry. To understand their results, let's first note the basic structure of wood. Two major wood components are cellulose and lignin. The lignin basically acts as a binding agent for the cellulose fibers. Several variations of the argon experiment were run, but the successful formula combined lignin and clay with heat, about 150 degrees Celsius, in the absence of oxygen. Over a period of about 8 months, artificial coal was produced. The rapidity with which coal can form when steam interacts with wood under pressure leads us to ask, can steam or hot water also produce the rapid transformation of organic matter to oil? An article, Water, Water Everywhere, published in the February 20, 1993 issue of Science News answers this question. Researchers at Exxon discovered water acted an essential part in the formation of oil. Efforts to synthesize oil met with failure until very hot water was added to the reactor vessel containing the source rock sample. When this was done, a layer of oil was found on top of the water at the end of the experiment. This result proves there is an alternate path to the production of oil in the earth, with superheated water playing a major role. The article indicated this discovery could wreak havoc with established ideas about oil formation. Actually, however, other natural events are already wreaking havoc with conventional theories. Incredibly enough, certain researchers, one at Oregon State University, have published reports showing evidence of present-day oil formation in the Guaymas Basin in the Gulf of California. Right now, in the Gulf of California, below 6,000 feet of water, is an accumulation of organic sediments derived from marine algae and other organic sources. Below this, superheated water is being pushed up by a deep heat source through these sediments. Oil is being formed in the interaction of organic sediments with superheated water. This hydrothermal oil from the Guaymas Basin is virtually indistinguishable from crude oils obtained from wells drilled in the earth. The implications of this discovery can hardly be overestimated. The possibility must be entertained that the genesis of the reservoir crude oils abundant throughout the world may be explained by hydrothermal processes similar to what's happening in the Guaymas Basin. But instead of an open dispersion of oil directly into the seawater, a closed system could easily be visualized where a reservoir of crude could be collected. It is conceivable that a worldwide flood was instrumental in the production of the tremendous oil reserves of the Middle East and elsewhere. The vast amounts of vegetation buried by such a flood, mixed with superheated water similar to that detected in the Guaymas Basin, could produce oil in the volumes we see today. Depending on the burial conditions, the organic matter would be transformed to either oil or coal. Is there a model of Earth history incorporating these features? One which allows the formation of the world's large oil and coal reserves over a much shorter time than has been previously thought possible?
What about a model based on the record of Earth's history given in Genesis? The Bible describes Earth being called into existence about 6,000 years ago, an Earth originally covered with lush vegetation, then devastated by a worldwide flood about 1,700 years later. This timescale certainly fits with all the scientific discoveries I've made, and just as certainly, water once covered this Earth. In 1927, Noel